Hi everyone. Let's talk about how to get the factors of an integer. Also, how to write an integer as a prime factorization. How to get a multiple of any integer, and how we can use these to get greatest common divisor (GCD), as well as the least common multiplication (LCM). Finally, we are talking about the division algorithm. Okay, we'll talk about the factor first. A factor of an integer is a number that divides n without leaving a remainder. If you have 12, 12 can be divided by 1 for sure, 2 because it's even number, divided by 3 because if I am adding this integer with this integer, 1 plus 2 is 3, so it can be divided by 3. Because this one can be divided by 2 twice, it's also can be divided by 4 without a remaining. Now, if we try to factor by 5, we'll have 2 and the remaining is 2. But so 5 is not a factor for this one. 6, no, when you divide it by 6, you get 2 without any remaining. 7, now you get 1 and the remaining will be 5. 8, the same, you have a remaining. 9, the same, you have a remaining. 10, 11, but can be divided by itself. Okay, so any integer can divide it by 1. So 1 is a common factor for any integer. Let's go for 18. 18 can divide it, of course, as we said, any integer can be divided by 1. This is even, so can be divided by 2. If I add 1 plus 8, it will be 9, so 18 is divisible by 3. If we divide it by 4, we have 4 and the remaining is 2 because 4 times 4 is 16 plus 2 is 18, so 4 is not a factor. 5 is also not a factor, but 6 is a factor, which is fair enough because it is divided by 2 and 3 at the same time, so 6 should divide 18. Of course, 7 is not a factor, 8 is not a factor, 9 is a factor. Okay. 10 is not, 11. So can divide it by itself finally. So all of these are a factor. Multiple is easy because multiple, it means you multiply it by 2, 3, 4, 5, 7, 6, 7, etc. So the multiple is just you have 8 and then multiplied by 2, it will be 16. So first you multiply by 1, multiply by 2, by 3, by 4, etc. Right? So you can have infinite multiples, right? Okay. Now, again, the factor is a number dividing the integer without remaining. The multiple is a number after multiplying by any natural number, 1, 2, 3, 4, 5, etc. So you have infinite number of multiples, but the divisors or the factors are finite number. Okay. So if you multiply the factor by the divisor or by the result of the divisor dividing, you will have the integer, right? Okay. Multiple of 5, again, multiply by 5 by 1, by 2, by 3, and you can carry on, okay? So you have infinite number of multiple. Now, which of the following number can be factor of 18? Which one can, of course, this is impossible because it's bigger than the integer itself. So the factor never be bigger than the integer. Also, this one, because you cannot divide it something by something bigger than this one. Also, this one. So the only one can divide this one. Shall we try it? Yeah, 18 divided by 2, you have 9 without a remaining. Now you can look at this one. and choose the true one. Factors can be greater than, yeah, we just said no, of course not. Factors are always less than or equal to the number, yes, because 18 itself is a factor for 18, okay? Factors can be any number. No, of course not. Cannot be any number. Factors are always prime numbers. No, of course, because 18 has 6 as a factor, which is not a prime number. Let's go for how to write any integer as a prime, as a composite number. If you have a composite number, how you can write it? What is the difference between a prime number and a composite number? A prime number, as we know, is only divided by itself and 1. But the composite number can be divided by any other number rather than itself and 1. So 2, 3, 5, 7, 11 cannot be divided by anything else unless itself and 1. But the composite number can be divided by, yes, it is a greater than 1, of course, it's a natural number. And it's not prime because the composite is opposite to the prime. Okay. Yes, 4 can be divided by 2 and 4 and 1. 6 can be divided by 1, 2, 3, and 6. Okay, now we know the composite is the opposite of the prime. Let's go for the fundamental theorem of arithmetics. Every integer greater than 1 can be written uniquely as a prime number or as a product of 2 or more prime numbers. Let's have this one. If we go for 20, I like to do this one. 20 divided by 2, you have 10. Divided by 2, you have 5, 5, 1. So I can write this one as 2 times 2 times 5. I know from the power rules, this can be written as 2 to the power 2. So this is how to write this one. Also, I get 54 and divided by 2, 27. I cannot divide it by 2 again, so I start with dividing by the next prime number, 3. I have 9, by 3, I have 3, 3, 1. Once I reach 1, I stop. So I can write this one as 2 times 3 times 3 times 3. Okay, so 3 multiplied 3 times, it means 3 to the power 3. This is how I can write this one. 62, let's go for 62. You start with 2 because it's even number. 31. 31 cannot be divided by 2 or 3 or 4 or whatever because it is a prime number. So you divide it by 31. So you can write this one as 2 times 31. 81, let's go for 81. 81, you cannot divide it by 2 because it's odd number. So you start by 3, 27 by 3, 9 by 3, 3 by 3, 1. Once you reach 1, you stop. So I have 3 multiplied 4 times. So I have 3 times 3 times 3 times 3, which is 3 to the power 4, right? This is how to write any integer as, they call it prime factorization. Now let's go for how to get the greatest common divisor between numbers, right? So yes, you have to write all these numbers, the multiple of this one, because we are talking about common multiple. So multiple, it means I multiply this one by 1, by 2, by 3, by 4. Okay, you can carry on. 12, 12 by 1, 12 by 2, 12 by 3, 36. Why I stopped? Because I find the same numbers appear here, right? Okay. So the least common multiple, the smallest number common between the multiples of these two numbers, 36. So 36 is the least common multiple of 18. Do you have another one? Yes, you have another one, but will never be the least one. Okay? You have common multiplication? Yes, but will never be the least one. This is how to get the least common multiplication. Now, the division algorithm, when you divide 12 by 5, for sure you have 4 and no remaining. Because 5 times 4 is 20. But if you divide 23 by 5, you have 4 and you still have 3 over 5. Sometimes people write it like that. Okay? So in this case, because yes, 5 is a factor of 20, so you have no remaining this one. But here, 5 is not a factor of 23, so you have a remaining. In general, if you're dividing A by B, A, you call it dividend. Okay, the number who divide the integer. The divisor is B. Okay. Once you have the division operation, you have a quotient, which is the result of the integer result of the division. If B is a factor of A, so when you divide it, you have no remaining. If B is not a factor, you have a remaining. So be sure you are not going to divide it by 0. Okay? And if you have a remaining R, in this time, B is not a factor. So when you divide it by any B, sometimes R is 0. R is 0 when you have B as a factor of A. This is the formula of the division algorithm. Now, divide 102 by 7 using the division algorithm. First, I go by dividing this one. Yes, I have 14, but I still have remaining. How to get the remaining? I multiply the result of the division, the integer result of the division, by, yes, by the divisor. So I get 98. Next step, I subtract this value from the original integer. So this will be the remaining. I can write 102 as the divisor, multiply by the quotient, okay, plus R, right? Okay. So this is the divisor B, this is the quotient Q, plus this is the remaining R, okay? So if I am dividing A by B, I have a quotient Q, and if B is not a factor of A, I will have a remaining R. Okay? If you have 83 laptops distributed evenly among 7 schools, how many laptops does each school get and how many are left? This is exactly what you are going to do. I'm just dividing 83 by 7. This is step 1. So the very close to 83 is 7 times 11, which is, yeah, I say 11. So I try 7 times 11, I have 77. The third step to get the remaining, because 83 minus 77 will be what? Yeah, I hear you, 6. I'm sure the remaining should be less than the divisor, right? Okay, because R should be less than Q, the quotient. The remaining should be less than the quotient. Now, how I can write this one? I can write 83 as 7 times the result, the integer result of the division, plus the remaining, right? This is how to, so I go for 11 laptops for each school, and the remaining left, how many computer left? 6 laptops. And how many are left? So I get this one. How many laptops does each school take? Is 11, right? Now, hashing algorithm to calculate hash values by dividing the key by the hash table size and taking the remainder. In hash table with 10 slots, so I have 10 slots. This is the table size, right? So this is the one. A key value is 123. So what you are going to do, you divided 123 by 10 and get the remainder to be your result, right? So how to do this one using the division algorithm? I'm trying 120 is the closest one to this one. This is exactly like, 10 times 12. Okay. Now I get 123 subtracted from 120. I will have the remaining 3. So, yes, will be placed in which slot? Slot number 3. Slot 3. Because he defined for me the hashing algorithm, how to calculate, which is a reminder of the division of dividing the key, which is 123, by the table size, which is 10. And the remaining will be the slot, the number of the slot. I think now you can go through all of these ones, stop the video, and you can solve these ones yourself. Thank you so much.